In this example, we're going to see how to use virtual functions and virtual destructors. So let me show you the base class. We have a base class called person. This is similar to what we had before. A person has a name and an age and a couple of constructors. Also, in this example, I have a virtual display function. The virtual keyword means the function is overridable. The base class does implement the function, and derived classes can override it if they want to. They don't have to, but they can override it if they like. Now, whenever you have one or more virtual functions in a class, you should also have a virtual destructor to ensure that objects get destroyed correctly. So that's the base class for a person, and I'll just show you the implementation. There aren't any great surprises in the implementation. We have the person constructors to initialize the object, and then we have the display function, and we have the destructor. Remember, when you declare virtual functions, you don't use the virtual keyword in the CPP file, just the header file. So in the header file, I declared the functions as virtual. You can't put the virtual keyword here in the implementation file. That would be a compiler error. Okay, so that's the base class. Now let's have a look at the student class. Student inherits from person, and in this example, I have chosen to override the display function. So in the student class, student inherits from person, defines some additional data, and has some constructors. That's all the usual stuff. And also, I've chosen to override the display function that we've inherited. When you override methods from the base class, it's good practice to put the virtual keyword again in here, in the derived header file, as much as anything for documentation purposes. Somebody that might want to inherit from this class in the future would see the display method, realize that it's overridable, and they could override it in their subclass if they wanted to. So for example, if you had a subclass of student called postgraduate student, it could override display if it wanted to. I've also got a virtual destructor here, just for the sake of example. So in the implementation for student, so we have the constructors, which initialize the person's, the student details, I should say, and then we have the student version of display. And quite often, when you override a method from the base class, quite often you want to call the base class version to do the basic stuff, and then add some additional processing to go a step further. So that's what we've done here. I've chosen to invoke the base version of display from the person class to display all the person related stuff. It's much better to reuse that base method than to try to display the name and age myself. Why not just delegate that method to the person's version of display? That's what it's there for. Notice that you have to specify the name of the base class when you override methods like this. Some other languages, like C# and Java, use keywords such as base or super to invoke a superclass method. But in C++, you have to give it the base class, the actual name of it. And the reason for that is because C++ supports multiple inheritance. So you could theoretically inherit from multiple base classes, both of which happen to have a display function. You will have to tell the compiler which version of the display function you want. It's the one in that particular class that you're calling. So having displayed the person's basic details, name and age, then we output the additional data for the student. So that would be the student's course. And then we have the destructor. Now with destructors, you never explicitly invoke your parent's destructor. It'll be invoked automatically. You can't actually, you're not allowed to invoke your parent destructor. It will just happen automatically. So what will happen is when a student object is destroyed, the student destructor will be called first to peel off the outer layer of the student object, if you like, and then automatically the compiler will call the base destructor afterwards. So destruction is always the reverse order of construction. With construction, the base constructor gets called, then the derived constructor. And with destruction, it's the opposite. It'll call the derived destructor first, then the base destructor. Okay, so that's our implementation for the two classes. Now let me show you the main code. So the main code is a little bit interesting. I've tried to illustrate polymorphism here. So first of all, notice I've created a student object, and the student object is going to have those details. According to the principle of substitutability, when you declare a base pointer or base reference, it is allowed to point or refer to that type of object or anything inherited from it. So this pointer P could point to a person or anything inherited from person, such as student. So what's going to happen when we call P our display here? Well, this is what happens. The compiler, when the compiler analyzes this code, first of all it checks, does the person class have a method called display? And obviously it does. There's the display method in person. So far so good. Then the compiler realizes that that method is virtual. So what the compiler will do is it won't decide which version of the display method to call until runtime. And at runtime, it'll care not about the pointer, but the type of object that it's pointing to. And that's because the function is virtual. The compiler, this is dynamic binding. The compiler will not decide at compile time at which version of the display method to call, but at runtime, it'll say what type of object is it actually pointing to at the moment. And obviously P is currently pointed to the student method, therefore it'll be the student version of the display method that gets called. So even though the pointer is a person pointer, the type of object it's pointing to is a student. So it'll be the student version of display that gets called, and that's all because the display function is virtual. If we hadn't declared the display function as virtual, none of that would have happened. The compiler would have just looked at the pointer and it wouldn't have cared what subclass we're pointing to. So the virtual keyword there is the enabler of polymorphism. So you have to remember that. If you want overridden methods to work properly, they have to be declared virtual. So that's going to call the student version of display. To illustrate polymorphism in a more compelling way, I've got two demo functions here, demo function 1 and demo function 2, and they both take a person pointers, the first one, and a person reference in the second one. Polymorphism happens here as well. In this case here, that's pretty much what I've just explained. PTR is a person pointer, but it's actually a student object it's really pointing to. So that's going to call the student version of display. And likewise here, references basically are pointers in disguise in C++. I mean, let's be honest about it. So when you invoke a virtual function through a reference, the same thing happens. It says, that's a virtual function. I don't know at compile time what kind of object you're actually going to be pointing to. I'll wait until runtime. And at runtime, it says, oh, that's a student object. And it calls the student version of display. So in each of these three cases, when I call the display function there through a base pointer, or there through a base pointer, or there through a base reference, in each of those cases, it will call the actual object's version of display, student. So if you don't believe me, I'm going to run this, Control F5, and you can see 3 times we've displayed the person, it's actually a student, 3 times it's displayed the person's name and age, and the course. So this is the student version of display that's doing all this. And it's doing it again for the second display function, and again for the third function. And then finally, notice, when I delete the object here, I delete P. So P is declared as a person pointer, because we know it's actually pointed to a student object. So because the destructor is virtual, it will look at the kind of object, student, and it calls the student destructor. Automatically then it also calls the base destructor to complete the tidying up of the object. So that's the end of the demo. We've seen that virtual functions can be overridden if you want to. When you define virtual functions, the system is intelligent enough at runtime to look at the object type, not the pointer type, to see which version of the function to call.